A very good evening to everyone. On behalf of Kriyavan Cyber Forensic Services, we welcome you all for the final and the last match 10 out of 10 of the CYBER T20 V3 series. Today we have our esteemed guest, Mr. Anant Rao from Cisco Systems. So we'll have a short intro about our speaker and then hand over the session to our speaker. Mr. Anant Rao is the technical manager for India and SAARC and Japan and Korea for Cisco Network Academy, Cisco Systems. And he has a wide range of experience with 14 years with Cisco as a technical manager for India and SOC regions. Before that, he was a learning consultant for Oracle Center, and he had quite a good number of experience with IFIM Business School as program manager and many other responsibilities. With Cisco, we know Anand sir as a senior person who's into training. Typically, we got introduced to Anand sir for attending Cisco's NetAcad trainings. So sir accepted for this session to be a part of final speaker for the 10 out of 10 match. So hopefully we'll have some hands-on experience today from Packet Tracer. So that's it from my side. Welcome you, sir. On behalf of CYBER T20 V3, we welcome Anand sir from Cisco.
Thank you,
the stage is yours, sir. Thank you, sir.
Okay. Is the screen visible?
Yes, sir.
Okay. So, hi everyone. So I was just checking the score because I'm a great cricket fan. So, what is happening in India and South Africa match, the real match. Okay. So, coming to this session. So, like what we are trying to do in this session is understand the layer 2 security aspect, which is very critical. So because once an attacker or adversary or a hacker enters the layer 2 network, which might be because of an APT or it might be a script kiddie or anyone, means any means, then they are into the, means they are very close to the crown jewel. So whether they want to attack, get the data, or get the source code, or get the credit card, whatever it is, they are very close if they are in the layer 2 part of the network. Okay, so because they have already breached the firewall and they have entered into the network. Now the concept of zero trust is there, which many companies are implementing. So even if they are inside the network, they will be asked for authentication, and there is they have to prove their authentication by whatever methods. So that aspect is one part when it comes to application and other things. But the other parts of the network, so if you go to a hotel or if you go to a company, it means if you happen to visit our company itself, there are certain ports which are open. Means what typically happens, or what typically should happen, is when they enter, they should be directed to a guest VLAN. So .1x authentication should happen, and then they should be actually directed to a guest VLAN where and a network segmentation would have taken place. So they wouldn't have any access to the corporate resources. So that is an ideal situation that should happen. Not every company implements .1x. Yeah, so it's not an easy protocol to implement also. So you need person who understands the significance of .1x and how it should be implemented and how to make it very scalable. Second thing is what I'm showing, what I will show will also be part of kind of wireless thing, because now the access, the initial access is basically wireless. When you enter an enterprise network, hardly you will see a wired thing, a port open. It's there. It's not that it's completely gone, but our laptops themselves don't have Ethernet port. Okay, so you have to find something where you will get an RJ45 connector, RJ45 to USB connector, that kind of a thing. So not many people are used to it. typically the executives and the marketing and other things. IT people will find some way to actually get a wired connection. So, but the concept remains the same, whether it's a wireless or wired. Okay, so wireless, it's much easier for me to launch this attack. Why I'm showing wireless packet tracer itself doesn't have so many capabilities it has for the wired part. So we could easily do this with the wireless part also. So means typically we actually use DHCP to get IP address. Okay, and if it's an IP version 6 network, then we'll use stateless auto configuration with DHCP for stateless DHCP. Okay, so auto configuration with stateless DHCP, or we can also go for stateful DHCP. So whether this will work for IP version 6, it might. Because of the address range and because of the scope, I have not tested this with IP version 6, and especially on a packet tracer thing. But not many companies internally still use completely IP version 6. So that possibility is also there. So, but let's enjoy the session, because I'm just giving you practical considerations. So, because you might think that, okay, this is not practical. This is very much practical, but there are some considerations which changes from an enterprise to an enterprise to an enterprise. Okay. Now, typically, what happens I have to. Okay. Is my screen still visible? I'm a WebEx user.
Yes,
I'm
sir.
not. Okay.
Packet tracer is visible.
Okay, good. So what happens in DHCP is, so dynamic host configuration protocol is the way you get an IP address. So without an IP address, you cannot communicate. Okay. So it's a kind of a catch-22 situation. I don't have an IP address and I want to communicate. So unless I get an IP address, I can't communicate. So with a DHCP server. So it's like, what should I do? Because and how will I reach DHCP server? Okay. So what this station does is it actually broadcasts. Okay. So I'll just go to simulation mode and just choose DHCP. Okay. Now if I go here and if I don't worry about the if you have not used packet tracer, don't worry about it. Packet tracer is just a tool. Understand the concepts. You can also implement this using Linux box also. So if I just get into DHCP, so the first message is always it's called as a broadcast message. Okay, and if you see here, actually the source address will be a one until it completes. The source address will be 0.0.0. Okay, so what station does is the station says, okay, please anyone a DHCP server, if any DHCP server is there, please respond. Can you give me an IP address? Okay, and other things. So DHCP server says okay, and it sends a, if it is there, it sends a offer message. Okay, then I will see, then I will request an IP address. Okay, and then I will the server will acknowledge. It's called as DORA. Okay, the logic behind it is much. Each message has a reason for it. Okay, now why we broadcast is the logic is very simple. I don't have an IP address, so I have to communicate with everyone. So I broadcast the DHCP message with the source address as 0.0.0 and the destination address as 252.252.252. So that's okay. So it's a local broadcast. It goes. That's fine. Now, why we send offer is two things. Is there might be some DHCP server which have a scope, so they can use, they have to usually target some stations or some MAC addresses and some part of the network. So not every DHCP server will respond to a broadcast, or it might have run out of IP addresses. So there is no IP address, so it will not respond. So don't think that every server will respond. The third point is why we need request. So our station is not the only station which is requesting for an IP address. There might be other stations which also might be requesting for IP address. Okay. So request is very important. So by the time I request, other server would have requested. Okay. Also, when I send a request, I'm asking for the server. Okay, please give me. And also other servers knows that okay, this server is contacting a particular server. So it's not every message has a logic. And when the server sends an acknowledgement message back, it is also for the client that okay, I have reserved you an address, I have given you an address, it's a lease. Okay, other servers don't bother about it. Okay, so each message has a logic. If I go into depth, we can have 3 or 4 hour session on DHCP itself, because each message, each part has a particular logic. The only missing part, if you see, is encryption. There is no security in DHCP, absolutely zero security. Okay, so it's a, if you see, means people say it's a poorly secure protocol, but I would say it's a very well designed protocol. So means for actual communication to happen, because many people say IP is not secure, IP version 4 is not secure, IP version 6 is also not secure. Many people don't know that. Only if you add security feature it will become secure. So the first part is communication should happen. Okay, then security should be a part of it. Now, if why this DHCP is not secure, or why DHCP is not made secure, is like, first of all, a station doesn't have an IP address. Okay, that is first part. Second part, there are some features, very what do you say, obscure features in layer 2 which are vendor dependent, which we can make it secure. Okay, so not DHCP, part of DHCP, but other part. Not every vendor has it. Okay, so the reason being, say suppose you take your laptop, you go to some hotel. Okay, and then that hotel might have an equipment which does not have that feature. So DHCP should still work, right? So you should still get an IP address. Otherwise, you should go and change your IP address to a static IP address. Not many people know that. Not many people know how to change an IP address, or how to find out which IP address your Android phone or your iPhone has. Not many people know that. Okay, so that's another part. The second part is, imagine in IoT world. Okay, so IoT world, we have very less memory. Okay, very uh, uh, rudimentary or very low end processor. Okay, so if I bring in encryption in these messages, those messages will be very processor intensive. And as soon as I bring encryption, so whenever someone says encryption, the first question you should ask is, how do you manage the keys? Key management. How will you securely distribute the keys? How will you store the keys? How secure is the storage? How often will you actually rekey the thing? So it's not easy. So it means many people I see will say encryption is the answer. Encryption is the answer if you have resources. Okay, it's like, if I go, very simple, if you don't have a house, you can't buy a house, you go and rent a house. Because of some budgetary constraints, you rent a house, or you don't want to stay in that city even if you have money. So there are, it's not that just buying a house is not a solution to a problem. Okay, now what is happening here is, so what I'm trying to say is, don't think that DHCP is a very poorly designed protocol and all those things. DHCP is a very good protocol. Okay, and now what happens is, so I have created a DHCP server on the router. So if I say, okay, so I have created a DHCP server. Okay, So if I go to show run, let me do a show run. That will be easy. So I've given three addresses, so like 253, 254. So the range is 1.1.0 to 5.5 means what I've done is I've excluded the first 252 addresses just to make this example work easily. Okay, I've given default router and DNS server. That's not a problem. Okay, now this is the only configuration which is there DHCP related on this server. So and then I have given 1.1.12 gigabit Ethernet 00, which is this part. So now if I come to this station and let me go and take this fast Ethernet interface, okay, just copy the address, okay, and then I will come and just paste this address, okay, and then come back to my thing. And now if I just what I will do is, if you see here, one address has already been given. Okay, so if I just rerun that command, so okay, so let me just run this once again, on and off, fast forward. Okay, then if this command is working on this, so it's not working, no worries. So if I come here and if I see the address, okay, now we will see. Okay, it got an address 253. Okay, you might not see it 1.1.253. So let me see whether what happened here. Okay, if you see here, it got an IP address 1.1.253. Okay, and then the same address, MAC address. So the MAC address is bound with this thing. So if I switch off and switch on this machine, that is, if I turn on the interface and turn off and turn on, and if you see the spanning tree is working, I will not go into explanation of that. I will fast forward this so that all the spanning tree conversation has ended. And then if I see here, the MAC address has not changed. Okay, and the IP address is also 1.253. Okay, it didn't change because the DHCP server has bound that. Now what if I change this address? Okay, so as an attacker, I know that everything is dependent on this MAC address. Okay, now if I come to this fast Ethernet interface, instead of 3380, I will make it 3181. Okay, and I will turn off this and turn it on and just fast forward this. Okay, so now the MAC address has changed. So if I come here and if I go to my desktop and go to IP configuration, you will see it's 254. Okay, now what if I do it once again, because the next address is 1.1.255. that address will not be allocated because it's a broadcast address. Okay, that will be for the network to manage the broadcast, to receive the broadcast. It will not hand it over to particular host. Okay, so what happens now is, if I come here and change the address once again, so let me make it 3382. It's an hexadecimal address. Turn it on and turn it on. Okay, and if you see spanning tree, that's okay. Now if I come here and if I see what IP address I've got, I have not got IP address. This is IP address. Actually the DHCP has failed. So if you see here, 169.51, 130. Now if I bring in other PCs also, now as I said, I am not the only person, right? So someone might come and join and log into the same switch. It doesn't matter if there is another switch, because the DHCP server is only running on the router. Now if I connect this, Now what happens is, and if I make it DHCP, a request, so let me just forward this. So again you say DHCP failed. So this is a typical DHCP starvation attack. Typical DHCP starvation attack. Okay. So it looks simple. It is simple, but how to prevent this? So how to actually prevent this attack? Okay, how to mitigate this attack? So what I will do is I'll just close this. And open packet tracer once again. Just give me a second. I should have opened that itself. Okay, no problem. Okay, now if I just open the folder. Okay, now if I come here and how to mitigate this? Can I do something on the router? Very difficult. What can I do is it's not a denial of service. It's someone changing their MAC address. Okay, I can prevent on the PC someone changing the MAC address. So the logic is, the first principle of security is whatever you do on the client side is not foolproof. Someone might get a software and might actually break that thing. It's like jailbreaking. Okay, what we do, or rooting of an Android phone. So now the next is switch. So there should be something on the switch which checks this. Okay, which says on this particular port only these two MAC addresses are allowed, or I will allow only 2 or 3 MAC addresses. I will not allow 100 MAC addresses. I know, like, only one, if only one port, only one station can connect, why I should allow many MAC addresses? So if you know the switch, the how switch works, so this MAC address will go here, means that frame will go here and it will check the destination MAC address and forward it, and the source MAC address will be added on the in the MAC address table. Now what we will do is we'll go to the switch, and we will configure something called as switch port security. Okay, we'll go to that particular port and we'll say, first we have to say port security. That's how it works. So it says command rejected. Now why it is showing it? If I say show, don't worry about the commands. Okay, don't worry if you don't know the commands. That's not a problem. Understand the logic. So if I say 01 switch port. So if you see here, it says the mode is dynamic auto. Okay. So when the mode is dynamic auto, it means that if it gets another frame, okay, depending on the type of frame, it can change its behavior. It's a dynamic behavior. It can become a trunk. Okay, trunk means it can carry multiple VLANs. So the thing is, what it is trying to convey is that it's in a dynamic state. So we have to disable that. So how to do that? We'll say switch port mode access. Okay, now if I do that and if I run that command once again, you will see that its mode has gone changed to static access. Now once its mode is static access, I can enable switch port security, and if I say switch port security, and I will say what maximum addresses you want, so I'll just say maximum is 1. Okay, only one address. Okay, there are other things here which says like if I say switch port, I can manually add the MAC addresses. Okay, I can make it sticky. Sticky means it will learn as and when it gets an IP address. But I just made a one MAC address. So what I'm saying, trying to convey to switches, just allow only one MAC address. Finish. Okay. Now let me just exit out, and then one more thing. So what happens if there are two? What will happen if there are two or more MAC addresses? Learned on this. So I'll say switch port. Port security violation. So what happens if there is a violation? So there are three things. One is protect mode, okay, which says block this, allow other traffic to go through, okay, and don't send means it doesn't send any log message. Restrict is it will send a it's same thing. Block this, allow other traffic, other ports, other things to communicate, okay. If it's kind of I have another switch attached or something like that, okay, but it also sends a syslog message and even SMTP trap message. Shutdown means shut down that port. Okay, shut down that port. So let's go here and see what happens now. We'll shut it down. Okay. Now let's go and see quickly. Nothing. So, and we can also say switch show because nothing has happened now as of now. Interface FA01. Okay. Now if you see it's enabled, it's up. Okay. The violation mode is shut down. Aging time, you can specify the aging factor. So aging type is absolute. Okay, you can say these many minutes. Okay, or you can have a relative thing. Okay, then other things are there, which so the maximum MAC address is 1. So and most important violation mode is shut down. Okay, so it has not learned anything. Okay, so now let's do this. Because I configured it after. So it got an IP address 253. Okay. Now if I go here, okay. Now it is enabled. Okay, so it's secured up. Maximum addresses 1 out of 1. It's done. So what happens if I change now? See here, it turned red. Let me fast forward, fast forward, fast forward, fast forward. Nothing will happen because it has gone to error disabled state. Now let's see what happens. So if I say show port security interface FA01, so it says it is shut down. Okay, violation happened. Violation count as 1. Now if I just say port security, so here is count as, if I can maximize this, so it says the port is shut down. Let me see whether I can show you the show interface, because this is a simulator, not everything is here. I want to see whether it shows error disabled. No, this just shows that it is a switch port. Show error disabled. No, it's not that. So in actual switch, I can see which ports are error disabled. Okay, and I can recover that. So I can refresh that or restart the switch or remove that MAC address, bring it back to original thing, and then do it. So let's see if I bring back to original thing whether it will work. I have not tried it, but let's see. No. So this is the difference. So I have to go and remove that from the error disabled state. Okay, you have to go to configuration mode, remove it. But it's a very thing. So like that's a very good thing. Okay. Now let's go and see another attack. let me just open from here. Now, one more thing is you can add the simulation mode and see what is happening here. Because of the time, it's a 2020 match. I cannot play a test match. Otherwise, I would have shown you all these things. Okay. So let me go and open it. I think it's 5. Let me see. No. Where did I store it? Okay. Just give me a second. I don't want to waste time designing that. Let me see whether it's this one. Yes. Okay. So I could have shown you how to design this, but that's not the point. Let me see. So this is a normal thing. So this is a 1-dot network and this is 2-dot network. So let me see what is happening here. Okay, 252 1.1. Is there a pool here? Okay, it will not allow this to remove. Okay, I'll just do two things quickly. I'll just change something here on the router. I don't want this router to be a DHCP server. Just give me a second. I'll remove this part. Okay, nothing is there. I need to do one part here. So first let me go back and do it static. Now if I do DHCP, it will not work. Okay, because I have removed the DHCP pool. So it's getting 169. That's okay. That's expected. Now if I go to, I will do two things. First I'll go to DHCP and I'll create a pool. So I'll say it as pool 1. This is a, imagine this is a Windows DHCP server kind of a thing. Okay, or a Linux running on a different server, not on a Cisco router. Okay, so default gateway, I'll make it as 1.1.1 and this is 2.2.2, this particular server. Start address 1 1 1, let's say 100 on whatever it is. So 100. So the first address should be 100. Okay, then add this, save this. Okay, and then what I've done is I've gone to DNS. Okay, I've created a record. So I can go to cisco.com, not the actual cisco.com. Okay, the one here and this one. This is the cisco.com for us. Edit, and I've said welcome to Cisco. So I have to go to DHCP and make it turn on. Okay, and DNS is on, and HTTP I have to make it on. Okay, now if I come here and still I will not get an IP address, and let me save this in case it crashes. Packet tracer in Mac has this reputation of crashing. If I do something once, so I'll say 81. Okay, now it will not come. Why? Because this is 2-dot network and this is 1-dot network. So this machine is sending a broadcast. It will reach here, routers stop broadcast. So what I have to tell is to this router is, hey router, hey interface of this router gig00, take this broadcast, convert this into unicast with your address and send it to the DHCP server. But the router will ask, where is the DHCP server? So that I have to inform the router. So I will go here and I will say interface gig00. I will say IP helper. The command is IP helper address. 2.2.2. So what I'm saying to router is when you get a broadcast, okay, typically the only broadcast which is happening here is the layer 3 broadcast is DHCP. So once you get a DHCP broadcast, DHCP, all the DHCP messages like discover and request which it will receive, convert that into unicast and send it to the station. And once this DHCP server responds back, then convert that unicast into broadcast and send it to the station. Okay. If you have Wireshark, you can run this, or if you have in Packet Tracer also run it. It will take time. I don't want to do that. So I'll come here and actually I will see what happens now. So it got an address 1.1.100. Now if I go to web browser, and if I say www.cisco.com, so I get welcome to Cisco. Everything is working fine, so no worries. Now there is a port open, so an attacker will come. Imagine that this is his machine. I can't show you a Kali or other machine because it's in Packet Tracer, it's not there. So we'll take a router and we'll connect to one of the ports which are open. Again, it can be a wireless port, it doesn't matter, the logic remains the same. So it is shut down, so I'll go to gig 00 port. And I will say IP address DHCP. I want to know whether all these ports are using DHCP. I'm not worried about the address. So, and I will say no shut. And I will fast forward this. If I come to the router, I'll get an address 1001. So I know that there is some DHCP happening and the stations which connect to different ports of the switch, once they turn on or turn off and if its lead time has expired, they will definitely go and request for a IP address. Okay. So now what I will do is I will come here and I will do this. Everything means in the typical real world scenario, everything is done on one machine. But just to show you, I can't do that on this router using simulator. So I will just build another network here. Quickly, I'll take a switch. And I will take a server, connect this, okay. Now I will do something else. So what I will do, will come to the router and I'll save this. Okay. So I'll come to this router and I will say no shut it down. I'll change the IP address. So I'll change the IP address to 3.3.1 255.255.255.0. I'll create a DHCP pool here. I'll exclude the address. I'll say DHCP first. I'll exclude some range 3.3.1 to 3.3.100. Okay, you can exclude anything. Okay, it's up to you. So then I'll create a pool, IP DHCP pool 1. I'll say network 3.3.0 255.255.255.0. Default router 3.3.1 and DNS server is 4.4.4. Okay. Now I'll come to this server. The other port, I'll come to other port, interface gig 01, and I'll say IP address 4.4.1 255.255.255.0. No shut. I have some work on this PC. I'll save this. I'll come to this server. I'll come to services. I'll just First, let me enable DNS quickly on, and I will say name as www.cisco.com. Address is 4.4.10. I have not given the address. I'll add it. I'll give that address. In the HTTP, just to make sure, I'll make this welcome to fake page. Okay, save this. Yes, overwrite that. And DNS is on, HTTP is on, and I have to do only one thing, configure the IP address. 4.4.10 tuftpy.tuftpy.tuftpy.tuftpy.0 4.4.1 and 4.4.10. Okay, and now I have to come to this router and turn on the other interface gig 00, no shut. Before I do this, I'll just save this and I will just fast forward. Now, there is no need for helper address here because the DHCP server is on the router. Okay, so only you need helper address when the DHCP server is on another segment, a different thing, and it has to forward the request. Sorry. Now, see what happens. So I got 3.1001, 3.3.1, 4.4.4. So if I now come here and if I say open the browser, and now if I say www.cisco.com, let's see where it goes. Host name. Okay, let me see why that is the case. Did I give? Okay, DNS server is 4.4.4. Very simple. Go here, desktop. Make this 4.4.4. Make this 4.4.4. Okay. Now come here. What did I do? Okay. Okay, fine. Now if I come here and go to desktop and go this way, fast forward this, so you'll get a fake page. Okay. Now this is a rogue DHCP server attack. Okay. So Ashok sir, shall I take 1 hour extra? Okay.
Yes, sir.
So just 2-3 minutes, nothing. I'll just
Sure,
explain
sir. Take your time, sir.
how to mitigate this attack. That's the only thing. So if you see what is happening here is, this is where it might crash. While I was testing, it crashed. So don't mind if it crashes. I have to open it. Okay. Because we are testing the limitations of packet tracer, edit filters, show or none. Edit filters, I want just DHCP. Now, what is happening here is very simple. Okay. So this might not be the case in everywhere. It means I could have done something like RF poisoning. It works on real world. Packet tracer throws some strange tantrums, like if I try to do a poisoning attack, it's because of it's a software thing, means it's a simulator. But in real world you can easily do that. Real world, unless operating system has some features built in, then it will, or if usually means like if there's a static thing, other thing, but let's not go into that. Now what is happening here is, if this user request, so let us see. And if I fast forward this, okay, now just see the flow of the message. Okay, it goes to the router. Router has a DHCP server, but this, the fake router, the actual router has to forward this. Okay, now by the time the actual router forwards it, the real router would have already sent the DHCP IP address. So once the station gets an IP address, once it's sent an acknowledgement, it's not like other protocol, it will change. It doesn't send a request. It says, okay, I've got an IP address, I'm happy with this. Okay, unless in your client configuration you want from a particular DHCP server. In your DHCP message, you can actually specify the DHCP server you want or where you want to extend the lease. That's a different scenario. Okay, then this might not work there. But again, these are all, we are testing the protocol security features or how protocol will behave in these abnormal situations. We can never say that it will behave in this way. We can't. So that depends on how the code reacts. There might be a bug in a code. It might crash also, which is bad, but it might happen. So not in packet tracer, in real world also. So since this station gets an IP address, this router gets a request quickly, fake router, it will send. Okay, and this router, the actual router has to forward this. So there is a delay. Okay. Now coming back, how to prevent this? In order to prevent this, what we do is we do something called as DHCP snooping. Okay, what DHCP snooping does is very simple. It goes inside the DHCP packet. Okay, and it allows the offer and the acknowledgement from only certain ports. It will not allow from other ports. So what we'll do is we'll say, see what happens here is, so we have DORA, discover, offer. Discover comes from the client, request comes after the server sends. Let me do this. So there's a discovery and a request. So before discovery, in order for station to send a request message, it should get an offer, and once it requests, the server should acknowledge. So this offer and acknowledgement comes from the server. Now what if I say that only certain ports are allowed to send this offer and acknowledgement? That port I will call it as DHCP snooping trusted port. Other ports can't send it. It will be blocked by the switch. Okay, because by default all the ports on the switch will be, if I enable DHCP snooping, all the ports will be untrusted. Only trusted ports can send. So I have to make specifically certain ports trusted. So what I will do is I'll go to this switch, and I will enable that. So I'll go and first say this is a strange thing. So I have to say IHCP DHCP snooping first, and I have to say snooping. Everything is in VLAN 1, so I'll make it as VLAN 1. Okay, then I'll go to this particular port FA0. Now you have to be careful. Let me explain this. So the server sends here. So only this port FA02 I have to make it trusted, not FA01. If I make FA01 trusted means this station is DHCP server. No, this station, this particular, all these ports are ports for client. So client cannot be a DHCP server. So I should know from where I'll get the DHCP message, DHCP, where the DHCP server is, and from where I'll get the message. So in this case, FA02 is where I'll receive that. So I have to be very careful where, otherwise it will not work. So I will say IP DHCP snooping trust. That's it. Okay. Now if I come here, now what happens if I do this? Two things happen. Now I will say show IP DHCP snooping binding. Nothing has happened because this is after I configured DHCP. So then if I say show IP DHCP snooping database, nothing has happened. Okay. So everything is 0, 0, 0, 0. Now what we'll do is we will do the same thing. Now I should, if typically everything works properly, then I should get a IP address from the 1.1.1 range. So I'll just do this, the actual thing. So I got 1.1.100 range. Now if I come to this server and if I say show IP DHCP snooping binding, this is very, very important. Okay, it says this MAC address is bound with this IP address. Okay, and it has this lease, this is DHCP snooping. Now if any station tries to do something, it will block. Okay, second thing is this is used in other attacks, means in other security features which to prevent ARP poisoning. So it is used in dynamic ARP inspection. It is also used something called as IP snooping, other things, so which we will see in some other session. So this database is used. This database becomes extremely critical. Okay, so anything it will check with this database if I have enabled this. Now if I say show IP DHCP database, snooping database, so it shows like total attempts, no failures and other things. Okay, successful writes. Now this is very, very important. Now if even if this it, like, let me show you the simulation mode quickly and let me save this. So this station is still receiving this. So the fake router is still receiving it, but it is getting blocked when it sends an offer or a request. So it's blocked by the switch. So only the actual station is receiving. So this particular thing is blocked. So it can't do it. Means even if it tries to send, the switch port sees FA03, oh, you are a untrusted port, so I will block the offer and the offer message is blocked. There is no question of acknowledgement. Okay, good. So try to continue your learning. I just showed layer 2 is, there are many things which we can do. We can do spanning tree attacks, we can do HSRP attack, we can do man in the middle, we can do router. There are many things. So, but this is a way you can learn how attacks can happen. Use packet tracer, try to learn the technology and do. That's it, Ashok sir, from my side.
Thank you, sir. Thanks a lot for the hands-on session, because we have got quite a good number of requests from participants saying like, so you're talking about cyber laws, cyber security, cyber forensics. We need some hands-on something on real world. So generally we assume like maybe when if you want to do an attack next finish, but simply trying a DHCP attack is this much complex, right? We need to just congratulate the hackers who try this on real world. Okay, sir. Thank you, sir. Thanks a lot. Participants, if you have any questions, queries, you can put in the chat box regarding anything, because anything regarding today's session. Sir is so good at bits and pieces of networks, network security. So you have any other general queries related to network security also? You can very well put in the chat box or raise your hand for unmuting. First, those who are new to network or network security, this might take a time for us to understand. But this is the bare minimal that is necessary for us to just get on to security, starting with the touch of security. So packet tracer is one of the most important and useful simulator tool which I have tried for quite a good number of years, being an instructor with SAM. So if you have any other questions offline, we'll just take it and we'll accumulate it and share it with the speaker. For time being, we'll just end with this second part of the session, first 20 and second 20. So on behalf of CYBER T20 V3 and Kriyavan's team, we thank our speaker, Mr. Anant Rao sir, for just giving a demo in the short simulated time. I hope every participant might have known about an attack, DHCP snooping, and how to prevent it. Thank you, sir. Thanks a lot.
Sure, sir. Any learning materials is like you can enroll into our courses or any you can refer. This what I showed is you will not find it. You will find how the protocol works. You will also find like some attacks, but hands-on is something. The network part you have to search, means you have to figure out. There might be some boxes, but packet tracer gives you a feel like you can with little resources, you can try to play around with it. So we have a skillsforall.com. You can go there. There are some packet tracer courses which are free. First learn. You need not be a master in packet tracer. Okay, so you just need to know how to cable, how to go to this part, and how to run a simulation if you want. There's a sniffer also. As Ashok sir pointed out, you can also do it in the real world if you have resources, both computer and other resources. So you need, if you run emulator, it will require a lot of memory. If packet tracer doesn't require that much memory, and then you means, I'm not saying because I'm from Cisco and this is our product, it's a very good product. Packet tracer is extremely good product, extremely friendly for anyone who is learning about networking. There are two things. One is you actually go into the network. That is first important part. Means network is where you face the first attack. Okay, so all the if you know how and nowadays it's encrypted because attackers are also have encrypted. There are tools which actually analyze the encrypted traffic also. Sorry, my voice today is failing me, but it's a good part to know how all this protocol works. So these protocols will not change overnight. So whether, and if you learn IP version 4, learning IP version 6 is not that difficult. Okay, so you can learn IP version 6 easily, but you should know how the protocols behave. What is the interaction between layer 2 and layer 3? What is the interaction between the various protocols? How protocols, you have to think like a protocol. Means you have to think like how a device processes the protocol. So then once you know how protocols will interact, then breaking the trust or making them to behave in the way you want becomes easy. So I saw in some Ashok sir would have also posted this, is everyone wants to become a hacker. Just jump to the fourth step or fifth step. Don't do that. First learn the fundamentals. You need not be a master. You should know how some basic thing works, and then you can actually become a very good person. Now I see most of the people want to get into fourth gear without even switching on the car or igniting the car. So that's the basic problem. I'm not blaming you. Don't think that this generation has that problem. Try to go to uh, fourth gear. Don't try to go to fourth gear. So just first and second, third are also important. Okay, so it's a very good, very interesting. Network security is very interesting. Again, there are two parts. One, if you want to go to prevention, where you can learn about your firewalls, IDSs, how to implement that, how all the other technologies work, or you can also go into how to identifying attacks, how to see how threat intelligence works, how attackers are working, how cyber gangs are working. That's also very interesting thing. You can go into malware analysis, other parts. That's also interesting. So, and also as sir pointed out, there are very other things like cyber laws. Most probably next year we'll get a new IT law. New IT law means we have IT law. We'll get a new modified IT law. Government is saying that, and then everything becomes, and IT law and cyber forensics are very closely related because you have to give the evidence. So all those things are interrelated, and this is a golden era for people who are learning security, and it will be for quite some time, unless there is a radical change in secure computing, which I don't see quickly. Okay, thank you, Ashok sir. Can I leave? Any other questions?
Yeah. Thank you, sir. Thanks a lot, sir. I hope that's it from participants' side.
Okay, sir. Thank you. Thank you, everyone. Have a